Hello students, I hope you all are doing good and preparing well for KCET exam. So in today's session, we will be covering application of integrals session. So you can expect around 1 to 2 marks from this chapter. So this is a important chapter. Uh, so before we start solving the question, will be revising the concept. So it is a basic concept. So we'll be quickly revising that, and then we'll be moving to our PYQ questions. Okay. Uh, okay, so what do we have? What have we got? So for a given curve, we have got these two curves. This is our g of x. This is g of x, and this is y of x. Okay, so between these two curves, we need to find the area. So first, and the limits that we have got are a and b. So first, between a and b, we integrate and we find the area f of x dx. This gives us the entire area, right? Entire area. Then we subtract the area that is bounded by this g of x curve, the g of x, the g of x and our x-axis, that is this area. We subtract this, right? Then we'll get our green region. So that is what we have done here. F of x minus g of x dx. So this is for vertical strips. Whenever we are doing vertical strips, it is with respect to dx. It is y dx. Okay, remember. Okay. And coming to the horizontal strips, when we have got horizontal strips, then again here this is our f of y, this is our g of y. Sorry, f of y, g of y. So first, the f of y dy. So this region we are subtracting with this region. First this region, right, the entire region, then the area that is bounded by g of y with the y-axis that we are going to subtract, right? That is we are subtracting, and the limits that we are following is c to d. That is what we have done here. C to d f of y minus g of y dy. Okay, so this is something like x dy, and y is the limits a to b. So remember these two things, but mostly we will be using this equation only, mostly, but depends. If for a given graph, if this is easier, you can apply this method or this method. Okay, moving on to the questions. Okay, so before we start solving the questions, I would suggest you to to pause the video and try to solve the questions on your own. Okay, so this way you will be able to develop your problem solving skills. Okay, so whatever the question that we are given here is area bounded by y equal to x cube, y equal to x cube, y equal to 8 and x equal to 0. Okay, let's take the easy ones. Okay, y equal to 8. What is y equal to 8? It will be something like this, right? Because the y coordinates are 8, x coordinate can be anything. X equal to 0. X equal to 0 is nothing but my y axis, no? So this is my, these two curves are done. Coming to this curve, y equal to x cube, it will be something like this, right? Okay, so as you can see, it intersects somewhere here. Okay, we need to find that point of intersection. Okay, only then I'll be able to find this point, right? I need this point. Okay, so let me just find that out. Y equal to 8 and y equal to x cube. 8 x cube, x equal to 2. So x equal to 2. So the point of intersection is 2 comma 8. Okay, so the bounded area bounded is nothing but this one. This is the thing we need to find out. So how will we find out? First, I'll be taking vertical strips. Okay, so first, the area bounded by this line with the y-axis minus the area bounded by this curve with the x-axis. Okay, so what I'll be doing, 0 to 2, 8 dx minus this area, no? I have to subtract this area. This area I need to subtract. So for that, 0 to 2 x cube dx I'll be doing. Okay, So I just need to integrate and find out. So what is integration of 8 dx? It is nothing but 8x 0 to 2. Integration of x cube is x power 4 by 4 0 to 2. 8 2s are 16 minus 1 by 4. 2 2s are 4, 4 2s are 8, 8 2s are 16. Okay, 16 minus 4. So the correct answer is 12 units. Okay, so I'll just summarize what we did. Okay, first we plotted the graphs on our plotted whatever is there on the x and y axis. Then we found out what is our bounded region, that it was this thing, right? To get that region, we came up with this equation and we solved it. Before that, we found this point of intersection. Okay, we substituted one equation into this and we found out the point of intersection. Using that, we got this point x equal to 2, so we have to integrate it between x equal 0 to 2. But the first region I added and second region I subtracted, and I got our resultant region. Okay, so this is the common procedure that you will follow to solve these type of questions. So they will be easy graphs. Okay, they will ask you easy graphs because you have to solve them in less than a minute. So the questions that they will ask you is simple graphs. Okay, they won't go complicated graphs. Okay, moving on. Okay, so this one is an interesting. So what is y equal to x square and y equal to 16? So area bounded by this region. Y equal to x square is something like this, right? So this is my y equal to x square. Simple graph. Everyone knows that. Y equal to 16. What is my y equal to 16? It is somewhere like this. This is my y equal to x square. So what is the region bounded by them? It is this region, right? So I have got 2 points of intersection, this point and this point. So I need to find that a point of intersection. How will I find the point of intersection? Y equal to x square and y equal to 16. If I put in this equation y equal to 16, what is the value of x? X is equal to plus or minus 4. So my point of intersection are minus 4 and 4, right? This is my 4 comma 16 and this is my minus 4 comma 16. Okay, this is 4 comma 16. Okay, so I'll just integrate it with 0 to 4 and I'll take twice of that because this is same, no? This and this is same. Okay, so my limits will be from 0 to 4, 16 dx minus this region. I have to subtract this region, right? So what is that? It is nothing but x square dx, 0 to 4. Okay, let me just find out this area. Let me call this 1. What do I get? 16x minus x cube by 3. This is nothing but 16 into 4 minus 64 by 3. What do I get? 2 times of 64 by 3, right? Yeah, yep. So this is nothing but 128 by 3. But I have to take twice of this, right? I have to take twice of this. So it is nothing but 2 times. This is just giving me this area. This and this is same, right? So I am taking twice of this. So 2 times of 128 by 3. This is nothing but 256 by 3. So the correct answer is option A. Okay, this is how you solve these type of questions. So it was a similar procedure that we followed. Moving on. Okay, the area lying between the curves y square equal to 2x and y equal to x is, okay, so y square equal to 2x. So this is a parabola, right? It will be something like this. Okay, and y equal to x is something like this. Okay, this is my y equal to x and this is my y square equal to 2x. So you might get a question, sir, how did you know that this y equal to x line is like this and not like this? It could be like this also, no? This is my y equal to x and my parabola could be like this. So so the point of intersection is only 0 comma 0. This could also be the case. I'll just redraw this. There could be two cases. Okay, Okay, this is my, say this is my parabola, and say my y equal to 2x only passes through 0 comma 0, then only one point of intersection I have. There could be either this one or this one, we don't know. Okay, so for that thing, what we can do is we can find out the point of intersection for these two curves, y square equal to 2x and y equal to x. I'll substitute this in this. Okay, if I substitute y equal to x, I'll get x square equal to 2x. So x square minus 2x equal to 0. That means x minus 2 is equal to 0. So x is equal to 0 or 2. So at 2 points, the point it intersects. At 0 also, at 2 also. So because I am getting 2 points of intersection, I have to consider this graph and I have to reject this case. Okay, so this is how we have to do. It can be like this also. If it is like this, if we were getting only 0 comma 0 as our point of intersection, then there is no area, then there is no region that is lying in between, then the answer would have been 0. Okay, so you have to remember that we have to consider both the cases. Okay, so what have we got? So this is our 0, this is our 2, right? So we have to find out this region. Pretty easy, right? The parabola region minus the y equal to x region. What will be my integral? Let me just write it slightly above. So my, what is my parabola? What is my parabola? That is y square equal to 2x. But what is my y? Y is nothing but root 2x, right? Plus or minus root 2x, but we'll be taking plus root 2x, right? Plus root 2x dx minus this region. This region I have to subtract, right? So it is nothing but x dx. My limits are nothing but 0 to 2. Simple, right? So what is the integration of root x? Root x, x power 1 by 2, x power 3 by 2 by 3 by 2. Okay, and integration of x is nothing but x square by 2. Okay, limits is 0 to 2, 0 to 2. So what do I get? 2 root 2 by 3, 2 power 3 by 2 minus 2 twos are 4, 2. Okay, so I get, uh, how do I solve this? 1 by 2, 1 by 2. Okay, let me just write. 2 3 by 2 is nothing but 2 root 2, right? This is by 3 minus 2. So root 2 is 2, 2 twos are 4, 4 twos are 4 twos are 8. 8 by 3 minus 2 is what I'm getting. So on simplifying this, what do I get? 8 by 3 minus 2 3s are 6 by 3. 8 minus 6 is 2, 2 by 3. So the correct answer is option A. Okay, so let me just summarize what we did. We found out the point of intersection. The point of intersection was 2 comma 2, and then the shaded region was this thing, the bounded curve. So first I have to take the parabola minus the y equal to x graph. Then we got our resultant area. Okay, so similar procedure we are following. Okay, okay. Moving to the next question. The area of the region bounded by the curve y square equal to 8x and the line y equal to 2x. So, okay, if you observe this question, this is similar to our previous question. Y square equal to 2x, y equal to x. We have got a parabola and a straight line. Okay, so I want this question to be solved by you guys. So try this question. So so this will be a good practice to you, and please let me know in the comments what you got. Okay, so what answer you got. Similar procedure we have to follow as the previous one, and I'll let you know whether you have done it correct or wrong in the reply section. Okay, moving on. The area of the region bounded by the curve y equal to cos x, x equal to 0 to x equal to pi. Okay, so what is the graph of cos x? Everyone knows, right? It is like this. Okay, this is something you should know. Okay, you should just remember the graphs. These are very basic graphs. So from 0 to pi. So area of the region bounded by the curve y equal to cos x, x equal to 0, and x equal to 0 to pi. So this is my region, right? This is my region. So these two regions are same. If I call this 1 and 2, 1 is equal to 2, right? Everyone agrees. So if I find what is 1, I'll just twice that. Okay, but my this is 0 pi by 2. So my limits, I know what are my limits, 0 to pi by 2. My curve is I know what is it, cos x. So it is a straightforward question. 0 to pi by 2, this is area of 1, and my curve is cos x dx. So what is integration of cos x? Sin x, 0 to pi by 2. Sin pi by 2 is 1, sin 0 is 0, so it is 1. So I have to take twice of this, right? Twice of area of 1. Area of 1 I have got as 1, so the correct answer is 2 units. Correct answer is option A. So this is how you solve these type of questions. Okay, uh, moving on. They have asked us area bounded by the curve. So we cannot tell that because this is below x-axis, both areas cancel and we get resultant 0. No, because they have asked us bounded by the curve, we have to consider both the areas. Okay, so the correct answer is 2 here, 2 units. Moving on. Okay, the area bounded by the line y equal to x, x-axis, and ordinates x equal to -1 and x equal to 2. Okay, so y equal to x is something like this, right? Oh, I'm so sorry. So something like this, right? Y equal to x. This is my y equal to x, and my x equal to -1. X equal to -1 is somewhere here, and x equal to 2 is somewhere here, right? I've taken it slightly here. So this is my the area bounded by the line. So I have to find this area, right? This is the area of interest. So what can I see? So this is you have to solve this within a minute. So don't use integration, I would suggest. What are you seeing here? I'm seeing two triangles here, right? If I can find the area of the triangles, I'll be able to solve the question. Okay, so what is this? This is my 2. So I have to find the intersection. This is my x equal to 2 and this is my x equal to -1. So what will be my this point? Because the line of intersection with y equal to x, because y and x coordinates are same. So this will be nothing but 2 comma 2 only. Okay, so I know what is the height now. The height of this triangle is 2. Similarly here the height is 1, right? Because this is -1 comma -1. So I have got two triangles. This is 2 units. Let me call this 1, let me call this 2. So nothing but 1 plus 2. What is my 1? Half. Base is 1 unit, height is 1 unit, plus the second region, the base is 2 units, the height is also 2 units. So what do I get? 1 by 2 plus 2. This is nothing but 3 by 2. Right? Pretty easy question. So the correct answer is option A. Let me check this once, please, guys. 1, 1, 1 by 2, half base into height, 2, 2, 2, 4, 2, 2 get cancelled. I'm left with 2, 2, 2 plus 1 by 2. I'm so sorry. 2 plus 1 by 2 is 5 by 2. No, it's not 3 by 2. I'm so sorry. This is 2.5. No. So the correct answer is option B. Okay. Moving on. Okay. So y equal to 2x plus 1. So it will be somewhere like this. No. So where will be y equal to 2x plus 1? So they are asking us the area of the region bounded by the line y equal to 2x plus 1 x-axis and the ordinates x equal to -1 and x equal to 1. Okay. So it is something like this. So this is my y equal to 2x plus 1 and x equal to 1 is somewhere here. X equal to -1, x equal to -1 and this is my x equal to 1. Sorry, I'll make it a little bit closer. This is nothing but x equal to 1, right? Okay, they are asking us, and x-axis, what is my x-axis? X-axis is nothing but this one. So we have to find this area. Let me just check. Y equal to 2x minus 1. Okay. Okay. I have done a mistake here. Okay, I'll tell you what is the mistake that I have done here. Okay, so this is my y equal to 2x minus 1. So this point is somewhere 0 comma 0 comma 1. So what is my this point? I have to find that out, right? So here if I put my y equal to 0, what is my x? X is equal to minus 1 by 2, right? So this point is minus 1 by 2. Okay, so my minus 1 is somewhere here. This is my minus 1, this is my 1. So the region is this thing. I am getting again two triangles. This has become slightly messy, I'm so sorry. So see, our curve is like this, and this is my minus 1 by 2. This is 1, minus 1. This is 1, same as the previous question, right? We'll first find out whatever is the height, and we have got two triangles here. Let me call this 1, let me call this 2. So all that you have to do is 1 plus 2. Okay, so even this question I want you guys to try and solve this question. It will be a good practice to you guys, and please let me know in the comments what you got. Okay, it is similar to the previous question. Okay, this is a slightly challenging problem. The area of the region above x-axis included between the parabola y square equal to x and the circle x square plus y square equal to 2x in square units is. Okay, so see, we have got a parabola, and this is a circle, right? X square plus y square minus 2x equal to 0. Let me write this in the standard form. What do it? X minus 1 square plus y square equal to 1. Okay, you can try this. I have written it directly. So this is what you get. Okay, that means the center is at 1 comma 0, right? Looking at this, so it is somewhere here. This is my center of the circle, and the radius is 1 unit. So my circle is like this. Okay, and my parabola will be something like this. This is my parabola. This is my y square equal to x. Okay, the area of the region. So with x-axis, so they are telling us the area with x-axis and this circle and this parabola. So I have to only find this area. Okay, so I have to first find out this point of intersection where this point intersects. Okay, so let me just find that out. We have got two equations, s square plus y square minus 2x equal to 0 and y square equal to x. I'll just substitute this here. I'll get x square plus x minus 2x equal to 0, x square minus x equal to 0, x minus 1 equal to 0, x equal to 0 comma 1 at 2 points, at 0 and at 1. So this is nothing but 1. So this is 1 comma 1. Okay, and this is 1. So I know right now, I've got the limits now. I can easily find that out. So first I'll take the circle. The circle is nothing but 1 minus of x minus 1 whole square minus, this is my circle, minus the parabola, right? Parabola is root x, right? Root x dx. Okay, so what is this? This is in the form of a square minus x square, right? What is the integration of root of a square minus x square? X by 2, whatever is there, the same thing, we'll just write it here. Then plus a square by 2 and sine inverse of x by a. Sine inverse of x by a. Simple, right? And then we have got minus integration of x power 1 by 2 is x power 3 by 2 by 3 by 2. So the limits, I forgot the limits, sorry guys, 0 to 1, 0 to 1. So 0 to 1, right? I have to just find that out now. Okay, so what do I get? So this part will become 0. Okay, when I put 1, this will be 0. When I put 1 here also, this will be 0. With this term I'll get something minus 2 by 3. Okay, Now when I put 0, what happens? It becomes minus 1 by 2. uh, this is nothing but 0, 0, 1, 0. Okay, again I'll get a 0. Yeah, minus 1 by 2 sine of minus 1. Okay, this is minus 1 when I put x equal to 0, and this term becomes 0, this term becomes 0. So again what I have got, minus 2 by 3 minus of 1 by 2 sine of minus 1. Sine of minus 1 is nothing but minus sine of 1. So it is plus 1 by 2 sine 1, right? So this is my answer. Let me check which of the following option matches. Okay. Oh, I'm so sorry. It is sine inverse, no? It is sine inverse x by a. I missed it. I'm so sorry, guys. So here it is sine inverse of minus 1. What is sine inverse of minus 1? 1 at is at pi by 2, so it is plus pi by 1 by 2 pi by 4. Pi by 2, so minus 2 by 3 pi by 4. Hmm? So the correct answer is 2 by 3 minus pi by 4. Oh, just a minute. What have we done wrong here? Minus of 2 by 3 plus pi by 4. No, so the correct answer is option D. I'm so sorry, guys. The correct answer is option D. So we have done nothing here. So first we found out the this thing, circle, minus the parabola, and that is how we solved it. I'm so sorry, guys. Here it is sine inverse of the quantity, not sine. It is the inverse trigonometric function here. Okay. It was a slightly lengthy question. It might take around 2 minutes. Say, yeah, it will take you time. So yeah, you have to compensate the time with some easier question. Okay. Moving on, the area of the region bounded by y-axis, y equal to cos x and y equal to sin x. Okay. Okay. First, let's plot what is y equal to cos x. Y equal to cos x is something like this, right? This is my y equal to cos x, and sin x will be like this. But we are interested only till 0 to pi by 2. 0 to pi by 2. So this is my 0 to pi by 2. This is my pi by 2, no? Okay. Area of the region bounded. They are asking us bounded with y-axis. This is my y-axis. So the region of interest is this thing, right? Only this region I have to find out. So I need to find out this point, right? So when is sin x equal to cos x? For which angle sin x equal to cos x? Tell me. Sine of 45 is equal to cos of 45. Everyone agrees? It is 1 by 2, 1 by root 2, right? So I can guess that this point is nothing but pi by 4, 45 degrees. So now the things become very easy. So all that I have to do is the cos, this is this graph is above. So cos x minus sin x. Sin x graph is below, right? So the limits is 0 to pi by 4. 0 to pi by 4. Integration of cos x is sin x. Integration of sin x is minus cos x. So this becomes positive, and 0 to pi by 4. So sine pi by 4 is root 2, 1 by root 2 plus 1 by root 2. Sine 0 is 0, cos 0 is 1. So this becomes 2 root 2. 2 root 2 is nothing but root 2 minus 1. Root 2 minus 1. So the correct answer is option A. So yeah, this question is an easy question. It can be easily solved in a minute. We need to find out the point of intersection. We just guessed it because at 45 degrees, sine and cos are equal. Okay. Yeah. So here, though, this was the last question of today's session. So what I would suggest is you just recap your first year textbook. So uh, learn how to draw basic graphs of parabola, circle, and ellipse. Okay. And basic straight lines you can revise. Okay. Okay, if you know all this, you can easily solve questions of this application of integrals. Okay, First, only thing we need to know is how to plot the graph, okay, and find out the shaded region, the point of intersection. Once we know the point of intersection, we get the limits, and we have to form the definite integral, okay, which one to take positive, which one to take negative. This is how you can find the shaded region. So you can revise these topics from your first year and solve all the problems that are given in your exemplar book, okay. So that with that much of practice, you can easily solve the question that is going to appear in the exam, okay. uh, okay, keep practicing, building your problem solving skills, okay. We'll meet in the next video, and if this session was helpful to you, please like the video, okay. Thank you.